Hello and welcome to another Max tutorial, although this time it's not just a Max tutorial. I'm going to also be using Native Instruments Reaktor software in order to demonstrate Open Sound Control, OSC. So how do we get different applications to communicate with each other? This is actually an extraordinarily powerful technique, and it's quite simple to use as well, but there's a few basic structural things about how OSC works that are not always understood. So I'm just going to start with basics and give you a bit of a tutorial. And this should be useful to you whether you use Macs or not, actually, so long as you have software or hardware that you want to have communicate and send information back and forth to control sound, to control video, lighting, pretty well anything, in fact. So a little bit of history here. Open Sound Control was developed at CNMAT, which is the Center for New Music and Audio Technologies at the University of California in Berkeley. And it was developed by Adrian Freed and Matt Wright back in 1997, I believe, if I'm remembering that correctly. And you can go to opensoundcontrol.org and get the full technical details on that. But all you really need to know is that OSC uses a system very like internet addresses. So, in fact, OSC comprises, an OSC message comprises an address followed by a type string, and then arguments. So we have an address, which is something like this. It's your basic internet style address with four integers separated by dots. It takes a type string, which can be I for integer, space this out a bit for you, F for float, S for string, and B for blob. B for blob, which is just a giant amount of information. So those are the four basic type strings it can contain. A lot of implementations actually extend those into things like arrays and other types of data types. And finally, the arguments. So once you specify the arguments using these letters, you can then basically have any number, 0 or more, arguments to send data to the address. Now, that's what OSC is doing under the hood, and there's different specifications for all of these. So for example, an integer is going to be a certain number of bits long and so on. But we don't need to worry about any of that. All we really want to know about is how addresses are specified. And again, it's specified, first of all, using this IP type pattern. And then the address pattern is actually a tree built up with slashes. So for example, I could have oscillators in my synthesizer, and say I've got a whole bunch of them. So if I want to send oscillator 4 a new frequency, it would be something like this. I specify comma F because it's going to be the comma means this is now a list of arguments. The F means it's a float argument, and then I would send it, say, 440 as a floating point number. Now, that 440 would be encoded in a particular way. It wouldn't go out as a bunch of numbers like that. It would go out as a bunch of bytes, a 64-bit or 32-bit number. Anyway, it would go out as something. We don't really care what the internal representation is. So this is what an OSC address looks like. Okay, fair enough. We don't need to worry about specifying the arguments. That is all done automatically for us in Max, but I'm giving you the details because in other software programs you might need to formally specify these different characteristics. Now, here's something really important. OSC is a content format. So it dictates what content would be like. It actually uses a protocol, user datagram protocol. There we go. It actually uses UDP as the protocol. In other words, UDP is how the information gets from place to place, and OSC is how that information is formatted. So they're two different things, but OSC travels over UDP. So UDP is one of the basic internet transports that was formalized back in 1980 or so. Others you may have heard about are TCP/IP and the protocols that are used for email. And there's quite a lot of other protocols as well. There's HTTP that is used for your web browser. They're all different ways of transferring data on the internet. The thing about UDP is it's lightweight and connectionless. Lightweight just means there's not a lot of structure around it, so you can send free-form messages. And it means that you can send OSC messages or other types of messages over UDP. And connectionless means that the sender and the receiver do not keep an open connection. Every bundle of information or every OSC message that's sent is sent independently. How is that done? Well, the sender, I'm going to write this down, requires an IP address and okay, so the sender requires an IP address and a port number. It's sending to a specific place on the internet. That can be your local internet, or it can be the worldwide internet. Not intranet. They both sound similar. So a receiver, though, only needs a port number. Okay, so there's a difference here. So the receiver requires a port number only. It's listening on a port because the receiver is already at a particular IP address. So every piece of hardware or software already is at an IP address. It does not need to specify that. The receiver port number is exclusive. So once a receiver binds to a port, as we say, or is listening on a port, no other receiver can use that port. This is a common source of error as well if you don't understand the way the UDP system works. So it requires a port number, and this port is exclusive. Okay, so this file is called OSC Dial, and what I'm going to do is just create a bunch, an interface. I'm just going to create an interface. So I'm going to get a dial like this, and I'll actually attach a float to it like this. Let me make it possibly bigger. There we go. Something like that will do. Let me give this a color. Make it yellow. And I will label it lemon. Whoops, didn't want to do that, did I? Make this chunky big. Okay, so if I lock my patch, I've got a dial. Oh, you know what? Let's make it a floating point. I always like my dials, as I've said before, to have float output 0 to 1, and that way I don't need to think about it. I know what the scale is all the time. It can be rescaled if I need. Right, so to send this out over OSC, we use an object called UDP send. And we need to specify some sort of an internet address. So I'm just going to give like a default local host address, which is 127.0.0.1. And we also need to give it a port number. I'm going to make one up, 7402. Whoops, I don't use the word port there. Sorry, it didn't like the message format. Now it likes the message format. Sorry about that. So that is a typical UDP send because we need to specify the IP address and the port. Now, to take this information, I'm going to format it with a name. Lemon. Give it a name. So I'm going to prepend lemon to that message and then just send that out. UDP send. Why not? Just send it out. And if I do this for a few other things, so let me copy and paste this. Call this one plum. Prepend the data with plum. Send that out to the same place. Change this color so it's a plummy color. There we go. There we go. It's a plummy color. Might be a little bit difficult to see because of the contrast there. Right, so I need to create a new file in order to receive this. Let me just save this first. And actually, while I'm at it, I will just add some of these things into my interface. Just to create a nice little interface here. Lemon and plum. How tasty you are. There we go. Right, now I'll create something similar as a receive object. A receive patch, and this way we'll have two separate max patches that can talk to each other without being connected in any other way. So this one is OSC Dial. So how about I save? Call this one fader. This way they'll be distinct. We'll be able to see the difference. So instead of this, I will put in some sort of a fader, slider, make it lemony good. Just make this a rectangle and connect that up and add that to my presentation. And then I can copy and paste for plum. Okay. And change that to look plummy. This way we'll have a visual. I'm specifying the colors just so we have an obvious visual way of connecting up the two as well. So just to see if these things work, no worries. Now in this case, we're not sending, we are receiving. So we use UDP receive. And it just takes a port number, as I said already. It does not require an address. Right. Tidy things up a moment, just because I like things to be tidy. Okay. Now, can we get both these on the screen? Like that. Whoops. Double click by mistake. Now, when I move these, nothing is happening yet. That's because we have not finished this patch by any means. Almost, actually, I shouldn't say by any means. What we need to do is, if you recall, this was sending these addresses, lemon and plum. So what we need to do is get rid of this part here. we need to receive those properly and send the information to the right destination. So we will use our root and whoops, lemon and plum. Do it that way. So we're using the addresses in order to send our information to the right place, which makes sense. Okay, save that. Save this. Okay, so now it works. Finally, so as I move the dial that says plum, it is taking 0.7, it's putting plum before it, so it will be plum 0.7, sending it out to port 7402 at this IP address. You don't need to formally specify the data type. Max figures out, oh, I'm getting floating point, so I'll put in comma F, before the argument. So some of the semantics are dealt with by UDP send, which is great because we don't want to have to deal with all that sort of stuff. So that's all it is. When you come to interface Max with the outside world, you'll notice a few issues. The first one is that this is not a valid address. A valid address has a slash before it, or a sequence of slashes. It's a hierarchy. So as my example was before, I had oscillator slash oscillator slash 4 slash frequency. So first we find our oscillators, we find the fourth one, we find the frequency parameter, and we send something off to that. So it's a tree. The address is a tree. It's a hierarchy delimited by slashes. So what I've just demonstrated is because the UDP send accepts any valid data, it doesn't actually know about OSC. It's accepting any valid data. It's massaging it in a way that is compatible with OSC, but there's a few things we have to do to ensure that it's compatible. One of the things is to put a slash before your names. So I'll need to do the same, of course, over here. And this works fine because a / is not a problem for Max to deal with, unlike some other meta characters. So speaking of the outside world, let's find Reaktor. Here's Reaktor, and I'll start a new ensemble. Now, if you're not familiar with Reaktor, that's okay. It's a visual development environment very much like Max, with a lot of differences, actually. It's superior in some ways and inferior in other ways. Basically, you can design a panel down here. It's like your presentation view. It's given me some input and output ports. I'm just simply not going to use those. I'm just going to go to my panel, choose a knob. Over here, I have an inspector that's similar to the inspector that we have for Max. It's got a bunch of stuff we can do here. So I'm going to call this plum. It's already a floating point from 0 to 1. I'll just make the default 0 for some reason. Doesn't really matter, I suppose. And then I will copy and paste that for lemon. Whoops, unlock my panel so I can do this. So one of the nice things actually in Reaktor is you have your two views open at the same time, which I really kind of like, your panel view. And actually there's more than one panel view, so you can create two interfaces for the same flowchart structure. Now, I'm not going to do anything with these at all. I'm not going to hook them up to anything. You might imagine that they're hooked up to a synthesizer, an effects unit, or whatever you want knobs to control. But that's all I'm going to do. I'm just going to simply put them there and then save this. I'm going to save this as OSC demo. There we go. I can lock this panel now. Now, in order to get Reaktor understanding OSC, you need to go into your settings and set up a couple things. So I've done this already. Basically, I've given it a port to listen on. It's using a different address here because this is an actual IP address on my local network. It's picked that up and there's not much we can do about it. So that's another difference between external and internal communication with Macs. So let's see if I close that. Under the connection tab here, I will add a source. And for the address, I will put in /plum. And for lemon, I will put in /lemon. Right, so now they have OSC addresses specified for each one. That's probably all I need to do here. I'm just going to close those up. How small can I make this? I can make this pretty small. Yeah. I can get everything on the screen at once. Yes. If you remember over here, OSC settings 192.168.1.6. So I need to send to that. So maybe what I can do is set this up with both options. Create a U menu. Set up for internal or external control. It can default to internal. And what I will do is, if it's internal, this is actually the information we want. So I want to send a host message and then a port message like this. And give us some more room for now. So if I select internal, I want to send this to UDP receive, which is the default, but let's formalize that. And if I want to control external software, I change the port number to 7401, which is what I have here in Reaktor. And I also need to change the host to the real address of this machine on my local internet. Now, I should stress that you can do this across the internet to other IP addresses. No worries. Or you could attach new devices to your local network, like, for example, your iPad or anything else that supports the internet. Attach stuff on Wi-Fi or what have you. And all the devices can talk together exactly the same as they are now. Okay. Let me make this part of my presentation view. So I can specify internal or external. Well, let's see. So if I specify internal, then I'm controlling my other Macs patcher. If I specify external, I'm controlling, oh look, Lemon's on the other side here. I'm controlling there. Perfect. Perfect. Here is a more extensive demo, and I will provide you with the code for this on my Patreon page. And what we have here, I've just extended it to 4 dials and 4 sliders. And with the connection set to internal, it works the same way as before, but it's bi-directional. So we can also now move the faders and the dials move. So it works both ways. They stay in sync. And this is very useful in lots of cases. For example, this fader view could actually be a mapping for your hardware surface. And you can use a standard patcher that represents your hardware with all the MIDI mapping set up and guaranteed, and then communicate from that to whatever patcher you're using at the time using OSC. Now, to get this going bi-directional, it's not a big deal. Essentially, we've got the receives as before, but this time we're careful to prepend set so that the faders and the float boxes are being set, but they do not trigger output. And this is to avoid a feedback loop between the two patches. And then when they do change, we simply prepend the address and send it out on another port. So we do exactly the same that this was doing. And here, this is listening as well. So they're symmetrical. You can see they're basically the same patcher, except with different UI elements. In this case, because we want it bi-directional. And this is listening on 7400. This one's listening on 7402. And of course, our Reaktor instance was listening on 7401. I hope you've enjoyed this tutorial. I will put these patches up on my Patreon page. Thanks for viewing. Be sure to comment there or here on YouTube. Let me know what you'd like to see in the future. If you have any additional questions, I try to pitch all of these tutorials at both beginners and intermediate users. I try to cover background in each case so that it's not just an isolated patcher, so it's something that you can learn from and extend into the future. And I hope I've been successful in my mission this time. My name's Robin. Thanks again for watching.